Hello class, today we are starting our unit on congruencies. So today we're looking at congruent figures and CPCFC. So your essential question is, how do I identify congruent figures? Your learning intention. I'm learning to identify congruent figures and their corresponding parts. So you've got two warm-up questions. This is over concepts you learned earlier in the year. So pause the video. Over here you've got 1, 2, 3, 4, 5 angles to find. Can you find all the angles? Well, I hope you tried. So if I'm looking here, without any math at all, I know this one is also 35 degrees. Now if I want to find these two angles, I'll take 180 degrees minus 35 degrees, and I will get 145 degrees. So the top and bottom are going to be 145 degrees. That's because they're vertical angles. Okay. What about the next one? Can I find this one without finding the last angle of the triangle first? No, we can't, because we don't know anything other than this is 100 degrees. So as I'm looking at this, to find this angle here, I'll take 180 degrees, I'll subtract the 35 degrees, I'll subtract the 100 degrees, and I will end up with 45 degrees. Okay, there's just one left. So, once again, I used the fact that we've got a linear pair here. These two angles are a linear pair, these two angles are a linear pair, and I will take 180 degrees minus 45 degrees, and I will get 135 degrees. We found them all. We used vertical angles, and we used linear pairs to find them all, and triangle sum theorem. So as I look down here, what do I notice in the picture? Well, you should say I've got this 90-degree angle here. So I know that I can't find this angle here without finding other angles. So I'm going to start here. This is 36, this is 84. What will this one up here be? Triangle sum theorem tells me that the sum of the interior angles of a triangle is 180 degrees. So I'll take 180 degrees minus 84 degrees minus 36 degrees. And what do you get? If you said 60 degrees, you were correct. So this is 60 degrees. Now, very quickly, if this is 90, this one's 60, I know this one is 30 degrees, because 90 degrees minus 60 degrees is equal to 30 degrees. And I did not do the degree sign very good on that one, so we will fix it. Okay, now for the last one, what do I do? Well, you're using the triangle sum theorem. All three of the angles add up to 180. 180 degrees minus 86 degrees minus 30 degrees. Put it in a calculator, and you end up with 64 degrees. So as you can see, geometry requires that you remember and think about all the concepts you've learned before. So when we think about congruence, what do we think? Congruent means what? Well, congruent means that they are exactly the same size and shape. So if a figure obtained by another figure by a sequence of rigid motions, then the two figures are. So you can take one figure, move it around, and you will, when you place it on top of the other, then they are congruent. Now, we're going to use the symbol, but I'm going to put congruent here so you know, if you don't remember. Okay, now, what does CPCFC mean? Okay, you might have heard it as CPCTC when we were talking about triangles. So the first C means corresponding. Corresponding what? P, parts. Of. What's the next C stand for? Congruent. What does the F stands for? If it was T, it would stand for triangles. F stands for figures. Are what? Congruent. Okay, so to shorten it up, because mathematicians hate to write, instead of writing all this out, we just write CPCFC. Okay, you've got two different diagrams. Describe the mapping that will prove that the figures are congruent. Okay, what do I do? If I'm looking here, I know that A and D correspond. So if I want to move A over to D, I would slide to the right and down. Now, we don't know how many units because we're not on a Cartesian plane. So I've moved it here, I've moved it down, but it's still not correct. What do I need to do? Well, number one, you need to reflect. And that would be over the segment DE. So now we've got it down here, we've reflected it up, and possibly we might have to rotate a little. But when you get down here, once you flip it up, it might actually go ahead and land on top of the other. But if it doesn't, then just rotate if you need to. Okay, what about the second one? The second one's pretty straightforward. What is it? Well, it's a reflection over the line AB or DE, whichever you want to call it. So So that one can be achieved by just reflection. So for the first page, we need to know what congruent it means. We need to be able to use the triangle sum theorem, the vertical angle theorem, and the linear pairs to find missing parts. Okay, corresponding pairs of what and corresponding pairs of what are congruent if and only if two figures are what? Well, when we look at a figure, what does a figure have? Angles and sides. And they're congruent if and only if the two figures are congruent. Okay, now, if we're looking and reading, we notice that it looks like they've made a mistake in their writing. It's got if and only if. That is not a mistake. That is the way we tell you that you can use the conditional or its converse. Okay, corresponding pairs of angles and corresponding pairs of sides are congruent if two figures are congruent. The converse, if two figures are congruent, then corresponding pairs of angles and corresponding pairs of sides are congruent. So it goes both ways. So you're given that the quadrilateral JKLM is congruent to the quadrilateral RSPQ. So we're going to list all the corresponding angles. So if I start with angle J, J is the first one. Over here, R is the first one, so it's congruent to angle R. What if I start with angle S? Angle S is the second. Angle K is the second. What about angle L? Angle P is the third. And the last pairs, M and Q. Okay, you notice I didn't even really look at the figures. And that's okay, because I know that when I pair them up, they've got to be in the same position on the congruent statement. So let's look at the sides now. If I look at the first two, segment JK is congruent to segment. First two on the last one is RS. What about segment JM? J is the first, M is the last. R is the first, Q is the last. Okay, let's start over here. How about the middle two? Segment SP is congruent to segment. SP is in the middle, KL is in the middle. So we've done the first two, the first and the last, the middle two. The last segment that will be congruent are the last two. So LM is congruent to PQ. So we know that when we're looking at the congruent statement, whatever is in the same position is going to be congruent. Okay, so on the next one, we're just looking and thinking. Given triangle HJK is congruent to triangle RST, find all the missing measures. So, do you want to do the angles first, or do you want to do the segments first? The segments might actually be easier. So, HK is 4.8. HK is first and last. RT is first and last. So this is also 4.8. Okay. ST, the last two, and JK, ST and JK are the same, 2.1 centimeters. And that simply leaves us with 5.2 centimeters for HJ, those first two, RS, the first two, and we're done. So now let's look at our angles. Angle J corresponds to angle S. So angle S is 61 degrees. Angle H corresponds to angle R. Angle R is 27 degrees. And for the last one, it will be 92 degrees. Using the congruent statement, we have just been able to find all of the missing measures. Okay, with this also we take a look back at proofs and we start working with proofs again. You're starting off with the two triangles are congruent. Okay, so this triangle here is congruent to this triangle here. And what we want to prove is that this side and this side of the quadrilateral are parallel. So how are we going to do that? What do we always start with? You always start with the given. Well, 99% of the time. So triangle WXY is congruent to triangle YZW, and that is given information. 100% of the time you end with what? What you want to prove. Segment XW is parallel to segment ZY. Okay, how do we get there though? Okay, so let's think back when we studied parallel lines. If you're looking at these two lines, this would be your transversal. Do we have any exterior angles that we can identify? No, all the angles other than your corners are inside of the two lines. So, if they're interior angles, which angles are congruent? Alternating interior angles. So I can state that angle, this is my alternate interior, XWY, is congruent to angle WYZ, which will be this one here. And how do I know that? Well, I've just said I've got congruent figures. So what comes next? That's CPCFC. Corresponding parts of congruent figures are congruent. Okay, now, I've just stated that my alternate interior angles are congruent. How do I know the lines are parallel? By the converse of the alternate interior angle theorem. I'm going to shorten theorem down to TH with a little m up above. So, you started out with what was given. You use the fact that you've got congruent triangles to state that corresponding parts are congruent. You state that they're parallel by a converse of the alternate interior angle theorem. So how do you know when you're successful? You know you're successful when you can identify congruent figures and their corresponding parts. So this is congruent figures and corresponding parts of congruent figures are congruent. So see if we can remember all that. If not, by the end of the unit, you will be able to remember corresponding parts of congruent figures are congruent. But we'll be switching to triangles next.